Let's start the programming series with Java Introduction, which will give you the fundamentals of the Java programming language. So, before we begin, please subscribe to our channel and press the bell notification on. Java has been one of the most popular programming language for many years. Java is object-oriented. However, it is not considered as pure object-oriented as it provides support for primitive data types, like int, char, etc. The Java codes are first compiled into bytecode, machine-independent code. Then the bytecode runs on Java Virtual Machine, JVM, regardless of the underlying architecture. Java syntax is similar to C++, but Java does not provide low-level programming functionalities like pointers. Also, Java codes are always written in the form of classes and objects. Java is used in all kinds of applications like mobile applications, Android is Java-based, desktop applications, web applications, client-server applications, enterprise applications, and many more. When compared with C++, Java codes are generally more maintainable because Java does not allow many things which may lead to bad/inefficient programming if used incorrectly. For example, non-primitives are always references in Java. So we cannot pass large objects, like we can do in C++, to functions. We always pass references in Java. One more example, since there are no pointers, bad memory access is also not possible. When compared with Python, Java kind of fits between C++ and Python. The programs are written in Java typically run faster than corresponding Python programs and slower than C++. Like C++, Java does static type checking, but Python does not. Before we dive into Java concepts, let's look towards its history. Java was developed by James Gosling, who was an engineer at Sun Microsystems. James developed Java in the year 1991, also known as Green Team. Java was acquired by Oracle Corporation. Let's look closely at the timeline. In the year 1996, Java 1.0 was released. In the year 1997, Sun Microsystems approached ISO standards for formalization. On November 13, 2006, Sun released JVM, which is free open source software. On May 8, 2007, Sun made available all JVM's core code under open source distribution. Hope you will remember this. Now, let's look at very basic Java program simulation. Here, we have two windows. One is input, where you can see the basic program in Java, which prints hello world, and other is output window for displaying the output of the program. Once you write your Java code and run the code, the JVM compiles the code and we get the output as hello world. Later in this video, we will explain JVM in depth. Before, let's dive into Java components. We have three types of core Java components. First one is Java Development Kit. Second one is Java Runtime Environment or JRE. And the third one is Java Virtual Machine or JVM. Now, let's understand each of them by its features. First is JDK. JDK is a set of tools/software bundle for development and compile. Its main component is JVM. It contains more tools like jar, console, Java, etc. Second is JRE. It is the software environment where compiled bytecode executes. It is implementation of JVM. JRE contains code required for running the program and native code. IT contains implementation of Java interpreter, garbage collector, class loader, class libraries and related files. Third is JVM. JVM is an abstract computing machine. Its input is Java bytecode. JVM is platform independent. JVM takes class files or the bytecode. JVM works on write once, run anywhere principle. JVM sits on top of OS/hardware to execute. It's a key component in Java ecosystem. There is one more key player component, which is the implementation JRE known as JIT compiler. JIT compiler is a component that is a part of JVM, and hence its implementation JRE. JIT runs when the Java program is interpreted, and its objective is to optimize the Java program and make it efficient. The Java program and performance, that's all about Java components. Keep these 4 terms stick to your head. You may see it often in use. Alright, next let's see what comprises of JDK and JRE. Inside JRE, we have Java Virtual Machine, library classes and development tools. Now, JDK is the combination of JRE and development tools, and JRE is a combination of JVM and library classes. Next comes WARA principle. WARA means write once, run anywhere. First of all, programmer writes the source program in Java. Then, it compiles the source code using Java's compiler to generate bytecode, which is class file. Now, the significance is that you can use this bytecode to run on any platform present, be it Windows PC, Linux or Mac OS. This makes Java language so reliable and easy to use. Now, let's understand how Java Virtual Machine or JVM internally works. Being a machine independent, once the Java code is compiled into bytecode, it doesn't need recompilation at every machine it runs. The input to JVM is the class bytecode, which goes to Java runtime engine for execution. First, it calls the main method of the corresponding compiled bytecode. Also, JVM do not load all the class files at once, rather it is loaded as per the requirements. Now, you might be thinking, who loads this compiled class bytecode into JVM? Answer is class loader. The Java class loader is a part of the Java runtime environment that dynamically loads Java classes into the Java virtual machine. The Java runtime system does not need to know about files and file systems because of class loaders, called by JRE. Next is JVM architecture. Mainly, JVM architecture comprises of 3 components. First one is class loader. Second one is runtime memory data area. And third one is runtime engine. We'll start by class loader. There are 3 phases of class loading: loading, linking, initialization. Let's understand one by one. Class loader, which is the first process in class loading phase, comprise of 3 types of loader. First is bootstrap class loader, in which all those system core Java API classes present in java_home/jre/lib directory called as bootstrap path are loaded by bootstrap class loader. Bootstrap class loader and a bootstrap class loader loads precompiled pre-trusted e.g. system.class file from rt.jar to the runtime memory area. Second is application class loader, which loads the class files from the application specific jars. After JVM compiles the Java code into class file, then application class loader loads the class file into the memory area. And third one is extension class loader. It is responsible for loading the additional class files from JRE, lib/ext folder. We may need class files such as OGBC driver to connect to external databases. In this scenario, we add third-party jars to extension folder. Now, the extension class loader make these precompiled class files available to JVM by loading the files into the memory area. Now, let's understand first process of linking phase, which is verify. Once the class files are loaded to the memory, there is a verify phase where bytecode class files are verified if they conform to standards. Second one is prepare, in which memory is allocated for the static variables and default values are assigned. And third one is resolve. In resolve phase, all the symbolic references are replaced by actual references. Finally, the last process of class loading is initialization phase. In the initialization phase of the class loader component, all the static variables are assigned with the actual values, and it also executes the static initializers at this point of time. Now, let's understand runtime memory data area section. It contains 5 types of memory area. First one is method area. Second one is heap area. Third one is stack memory. Fourth one is PC register. Fifth one is native method stack. Inside runtime memory data area, first one is method area, where all class level data area stored in this memory area. Second one is heap area, where all the objects and instance variables are stored. Third one is stack memory section, which contains local variables. Operand stack. And frame data. Frame data acts as a cache block information in case any exception occurred within method. Fourth one is PC registers. PC register keeps track of current executing instructions at any moment. Note that, if the current executing method is native, then the value of the program counter register will be undefined. And the last one is native method stacks. Native method information and created per thread. If the native methods cannot be loaded by a JVM, then it need not have native method stacks. Memory size is managed similar to general JVM stacks like fixed or dynamic. JVM will throw stack overflow error or out of memory error accordingly. Stack overflow error is the computation in a thread requires a larger method stack than is permitted. And out of memory error occurs when, in case of native method stacks expansion, attempt but insufficient memory can be made available or initial native method stack. Keep these important concepts in mind. Alright, finally we will understand about execution engine, which is the most important module, which is third component, and it converts byte code to corresponding machine code. Then it performs execution respectfully. It has four main submodules. First one is interpreter. Second one is JIT compiler. Third one is profiler. And fourth one is garbage collector. Interpreter reads class files or byte code and executes it one by one. When a method is called multiple times, it interprets those lines of byte code again and again. Second one is JIT compiler, which helps in overcoming the problem of the interpreter. What happens when repeated method calls occur? JIT compiler compiles the byte code to native code. Now, this native code will be used directly for repeated method calls. JIT compiler contains few components to achieve this feature. If we look into internals of JIT, we have intermediate code generator, code optimizer for better performance, target code generator, which converts intermediate code to native machine code, profiler for finding hotspots, methods which are called repeatedly. Interesting, right? Third component is profiler. Profiler is used for finding hotspots, methods which are called repeatedly. And the last important component is garbage collector. Garbage collector is responsible for destroying the objects that are no longer used. Before coming to an end of this video, let's look at Java interesting facts you might be not knowing yet. Java is simple and secured programming language which makes it unique. Original name was Java Oak in the beginning. Java is rich aromatic coffee seed. It was an accident. Java is the highly paid language in career. Most popular language, number 2 position, after C. Junit is the top used Java technology in recent times. About 95% of the organizations use Java programming languages. Latest Java version is Java Standard Edition 8 with improved productivity and app performances. It runs on more than billion smartphones since Google's Android operating system uses Java APIs. There is no print function in Java, but it was there in Java version 5. There is no concept of pointers in Java. Its basic syntax includes 4 components: object, class, methods and instant variables. Java includes different type of built-in data like strings, numbers and booleans. Java can be used in any platforms. Interesting, right? Thanks for watching this video. If you like the explanations, please subscribe, like and press the bell notification on. Follow me on Instagram, Twitter and YouTube. Next, in upcoming video, I will show how to set up Java environment in your PC. So, stay tuned. Thank you and namaskar.